for lab 6, code was to be written so that the robot would drive straight, and utilizing the ultrasonic sensor, it would detect an object 80 centimeters away, and then stop, and then have the distance remaining, and then drive that distance, have it again, drive it, have it, so on and so forth, half it, so on and so forth, until the object is 5 centimeters away. So in my code, I have my magic numbers. So wheel diameter, the robot counts per revolution, KPI to KP for my drive straight function. My trigger pin is connected to pin 11, echo pin 2, and then this distance travel per encoder pulse. Then over here I have my setup function for serial connection, and then to just setting the trigger and echo pins. Then I have my loop function. So I have my button press, and then when the button is pressed, the LED turns on for the 2-second delay for the button press, the LED is on, and then it turns off. And then this is my while loop. So float distance, I have my functions, my get filter distance down below. So delay 500 is for the sensor to get half-second readings. Every half-second, it will read the distance from the robot. So I have, if distance is greater than 80, the robot will drive straight at these speeds for 250 motors, and then when it's within 80 centimeters of the object, it will stop. Then there's a delay, and then it will have the remaining distance, divide that by 2, and then move closer, so on and so forth. And then if remaining distance is less than or equal to 5, have it so that the robot stops, and then there's a red LED that turns on forever until the next button press. Until the robot reaches 5, it will just keep driving straight. So this is my ultrasonic sensor function for get filter distance. So the number this is 5, so because the robot will stop 5 times, so it goes to 80, then half of the distance remaining, which would be 40, and then 20, and then 10, and then 5. So it will be 5 readings. So I have a for loop for this. Then I use an array. Well, first off, this over here is this calculates the time for the signal with pulsing the echo pin high. It calculates the time for the signal to return, and then by dividing it by 58, I get the distance in centimeters. So I had this for loop for the array, which is a bubble sort to find the median reading. So I have all of this. There, take the reading. Then I have my drive straight function, calculate my pulses required. Then reset the encoders. While loop for the encoders. So I added the KP for the gain. I use gain to get feedback, like real-time feedback, so that the robot will drive straight. Cause my left motor is weak, so it corrects it so that the right isn't overpowering the left motor. Then I just have my wait for button press function. So I'm gonna upload my code to my robot over here. Also, yeah, I have the ultrasonic sensor at the front right here. So I'll upload my code. So I place it over here, have the 120. So I have the ultrasonic sensor at the 120. So just like that, 120. This is all 120. Have it measured from there to here is 120. So I'm gonna press my button there. And then the red LED comes on. I mean the green LED turns on for 2 seconds. So like 80, it stops. Then next, at 40, and at 20, and at 10. Oh, yeah. And then the red LED turns on forever. So, and then if I press it again, see it, and it loops. Yeah.